Hi everybody!
Happy New Year!
Happy New Year!
It is now 2021, and I got a feeling that this year we'll see interesting chemical reactions. For today, we're gonna be making an explosion, but with water instead of a fuse. Now normally, when you think of an explosive, you think of lighting a fuse and then BAM! However, this time, we're gonna be using a drop of water to blow up some zinc. All you need is 8 grams of ammonium nitrate, 2 grams of ammonium chloride, and 8 grams of zinc powder. The principle here is simple. It's actually because we are mixing an oxidizer and a reducer. In our case, the oxidizer is ammonium nitrate and the reducer is zinc. Let's see more about it in the explanation. For now, let's see our reaction. So first off, let's mix the ammonium salts. Ammonium nitrate.
I'll crush it.
And ammonium chloride.
How much I have to wait to crush?
Now you can grind it.
Thank you.
If your reagent sizes are too big, I recommend grinding them up into a powder.
Now, what are we gonna do with this powder?
We're gonna have to mix it with zinc and then just put a drop of water on it.
Then what color flame was it?
Well, it will most likely be green.
Yeah.
Because zinc's flame color is green.
Yeah.
Okay. Now that we got that, let's just get out my mortar and pestle. Now our mixture of ammonium chloride and ammonium nitrate is complete. We're gonna have to mix it with the zinc outside because the mixture becomes incendiary. In other words, it catches fire real well. Note the fact that you should not be doing this experiment if it's raining outside or even if it's humid outside because high humidity can even cause it to explode. Outside, I will be mixing the two components together. Ammonium chloride, ammonium nitrate, and zinc. Once I mix the two, I will add a drop of water from this.
1 drop.
Now, once we go outside, let's make an explosion with a drop of water. Ready, everybody?
Ready.
See you outside.
See you
Bye.
outside. Bye.
Okay, so now let's make our mixture called negative X. Ready.
Set.
Wait.
Go!
Now, let's see the reactions involved. The main reaction here is shown. The reaction here means that zinc powder, a solid, reacts with aqueous ammonium nitrate or ammonium nitrate dissolved in solution, is catalyzed or sped up by chloride ions from the ammonium chloride to form solid zinc oxide, gaseous nitrogen, and gas water vapor. In theory, the zinc oxide that I just made could be used to make sunscreen. However, it's a bit too polluted for that. Now, let's go ahead and see the oxidation states. So here I changed the board to list the oxidation states. Zinc is 0, the nitrogen and ammonium is -3. All of these hydrogens are plus. these oxygens are -2 as usual, and the nitrogen here is nitrogen 5. Nitrogen 5 has a freakishly high oxidation state, which makes it a strong oxidizer. This is typical because a lot of the substances that have an oxidation state of like 5, 6, or 7, which is really high, tend to want to oxidize other stuff, like permanganates, chromates, dichromates, and nitrates. Now, you can see that the zinc was oxidized to zinc 2. So, clearly, zinc is the reducing agent. So, this guy was oxidized. I know, it's confusing, but it's considered a reducing agent, even though it was oxidized. Next, you can see that this nitrogen here got oxidized to nitrogen 0. So, this guy also got oxidized. However, the nitrogen 5 here got reduced to nitrogen 0. So this guy was reduced and therefore is the oxidizing agent. Now you can see that the oxygens and hydrogens didn't change the oxidation state. Next, let's see why I added the water, or why we need water to trigger the reaction. You can see that I drew two sides, S and AQ. S means solid, and in solid state, ammonium nitrate has a crystal lattice structure. It means that the cation and anions are in this crystal-like structure. There, though, it just moves around and vibrates a little, and it can't move around freely. However, in solution, in other words, AQ, it can move around freely in the form of ions. You can see that I drew them all here. However, you also see the ammonia and protons. This is because of the ammonium ion, which is the conjugate acid of ammonia. Ammonia is a weak base, so its conjugate acid should show some acidic properties. So you can see why I drew this hydrogen ion. Now let's see why the flame was mostly green. Now this is actually the same principle they used to make fireworks. The zinc here has many electrons. One of the electrons get excited because of all that heat from the reaction. The heat moves it up to a higher orbital because in the higher orbital, things tend to have more energy. However, the electrons aren't really that comfortable with the higher orbital, and they instantly give off all of their energy in the form of light. Then, the electron returns to its normal state, and it gets excited again, and the process repeats. Next, I'll show you what the smoke was. Note the fact that you should not breathe the smoke. The main reason is that zinc solid tends to turn to zinc vapor. The zinc fumes are very toxic for your health. Also, the ammonia. Also, zinc boils at around, let's see, more than 1,600 degrees Fahrenheit. So, the water boils and another reaction occurs. Probably, the breakdown of ammonium chloride also happened as well. You can see that I drew it here. In intense heat, the ammonium chloride breaks down into its components, ammonia and hydrogen chloride. However, because above the reaction is quite cold, it recombines into ammonium chloride again. So, all that smoke was mainly zinc vapor and ammonium chloride that managed to escape. Thanks for watching, and see you in our next chemical reactions. Bye!